But welcome back. Let's do question 3A1. We have to prove this identity here, but if you check here, you can see that we have to use the double angle formulae. Right, we have to use the double angle formulae. So remember that cos 2 theta is equal to 2 cos squared theta minus 1, or you can say it is 1 minus 2 sine squared theta, or you can say is cos squared theta minus sine squared theta. Okay, and then remember that sine 2 theta is equal to 2 sine theta cos theta. Okay, and then tan theta, we know tan theta is sine theta over cos theta. Okay, so we're going to use all the three, but in the exam you don't need to do all of them. You just choose one, isn't it? Okay, but I'm going to show you how to simplify this identity using all these three identities forward or formulae forward for cos 2 theta. Right, the double angle formulae there for those. Now, let's start. We're going to start with the first one, 2 cos squared theta minus 1. So now it means where there's cos 2 theta, we put 2 cos squared theta minus 1. So it's going to be 2 cos squared theta minus 1, and then plus 1. Remember, this one is replacing cos 2 theta. So it's plus 1 over, what is sine 2 theta? This is 2 sine theta cos theta. Okay, then plus sine theta over cos theta is equal to 1 over sine theta cos theta. Okay, right. And then what is negative 1 plus 1? That's 0. So we remain with 2 cos squared theta minus 1. No, not minus 1. This one is gone. So we just remain with 2 cos squared theta. Negative 1 plus 1 is 0. And then over 2 sine theta cos theta plus sine theta over cos theta is equal to 1 over sine theta cos theta. Okay, right, and then 2 divided by 2 is 1, and then here we have cos squared theta, means that cos theta times cos theta, so we can cancel 1 cos theta here and remain with 1. So it's going to be cos theta here, and then we cancel 1 cos theta there, so we're basically remaining with cos theta over sine theta plus sine theta over cos theta is equal to 1 over sine theta cos theta. See that? Okay, so if you check on the left hand side, we have to simplify these two fractions, and then our LCD is going to be sine theta cos theta. So we multiply this one by sine theta by cos theta, so that our denominator is cos sine theta cos theta. So it's going to be cos theta over, sorry, sine, this is sine theta, then times cos theta over cos theta. Okay, so that our denominator is what? Sine theta cos theta plus sine theta over cos theta, okay, times sine theta, okay, times sine, what am I doing? This should be sine theta, ne? Sine theta. Right, okay. And then let's come this side. And then we can say cos theta times cos theta, that is cos squared theta. Okay, this is, okay, cos squared theta over sine theta cos theta, and then plus here sine theta times sine, oh, I forgot to write the right hand side here. Okay, sine theta cos theta. Right, sine theta times sine theta is sine squared theta over sine theta cos theta. Okay, cos theta sine theta, just the same as sine theta cos theta. Multiplication is commutative, remember that. And then now our denominators are the same. We can add the numerators. Cos theta there. So cos squared theta plus sine squared theta is going to be cos squared theta plus sine squared theta over sine theta cos theta is equal to 1 over sine theta cos theta. Okay, and then what is cos squared theta plus sine squared theta? This is 1. So we're saying 1 over sine theta cos theta is equal to 1 over sine theta cos theta. So we prove that the left hand side is equal to the right hand side. Okay, so we're going to use the next formula. Okay, because we're going to use now the next one, which is this one. Okay, right, let's go there. Now we said we're going to use for cos 2 theta, we're going to use 1 minus 2 sine squared theta. We see that we're going to prove our identity even if you use it. Okay, so now this is going to be 1 minus 2 sine squared theta. 1 minus 2 sine squared theta, then plus 1, this one here. Okay, plus 1 over 2 sine theta cos theta. Okay, plus sine theta over cos theta. This is tan theta. And then it's equal to 1 over sine theta cos theta. Okay, right. And then what is 1 plus 1 is going to be 2. So this is like 2, and then minus 2 sine squared theta over 2 sine theta cos theta plus sine theta over cos theta is equal to 1 over sine theta cos theta. See that? Okay, what do you think we must do now? We have to factorize. We have to factorize this one here. So it's going to be 2 outside here. It's going to be 1 minus sine squared theta. We know what 1 minus sine squared theta is, okay? I'll just remind you now. And then this is 2 sine theta cos theta, right? And then plus sine theta cos theta is equal to 1 over sine theta cos theta. Okay, 2 divided by 2 is 1. But remember that from this identity, we do this in grade 11, isn't it? Cos squared theta plus sine squared theta is equal to 1. And then from this, we know that cos squared theta is equal to 1 minus sine squared theta. And then we know that sine squared theta is equal to 1 minus cos squared theta. So now we know that 1 minus sine squared theta is going to be cos squared theta. So we write that. So it's going to be cos squared theta over sine theta times cos theta plus sine theta over cos theta is okay, it's equal to 1 over sine theta cos theta. Okay, right. And then can we divide right, what can we do here? We can even, yeah, you do this, we can do this, thing differently. It's fine. We can, because if you remove this cos theta here by dividing, we'll have to bring it back to get our LCD, isn't it? So let's just leave it there and then multiply this cos theta, the denominator here, by sin theta, so that we have the same denominator to get our LCD. Let's just do that here. So we're going to multiply this by sin theta. Okay, so it's going to be cos squared theta over sin theta cos theta plus sin theta over cos theta, and then times sin theta, so that we get our LCD times sin theta, okay, is equal to 1 over sin theta cos theta. Okay, then what do you get from that? Cos squared theta over sin theta cos theta plus sin squared theta over sin theta cos theta is equal to 1 over sin theta cos theta. Okay, and then what is cos squared theta plus sin squared theta? Because the denominators are the same now, so we can add the numerators. Plus sin squared theta over sin theta cos theta, then is equal to 1 over sin theta cos theta. And then cos squared theta plus sin squared theta is what? Is 1. So it's going to be 1 over sin theta times cos theta is equal to 1 over sin theta cos theta. See that? Okay, and then we've proved that the left hand side is equal to the right hand side. Okay, so we're going to use the last one, which is saying cos 2 theta is equal to cos squared theta minus sin squared theta. Okay, let's go to that part. Cos 2 theta is equal to cos squared theta minus sin squared theta. So we replace this with cos squared theta minus sin squared theta. So it's cos squared theta minus sin squared theta plus 1 over 2 sin theta cos theta, then plus sin theta over cos theta is equal to 1 over sin theta cos theta. Okay, right, so we have this. What do we do from here? What do we have to do? So we can find our LCD here, which is 2 sin theta cos theta. So we have to multiply this fraction here by 2 sin theta. The numerator we multiply by 2 sin theta, the denominator by 2 sin theta. So it becomes cos squared theta minus sin squared theta plus 1 over 2 sin theta cos theta plus sin theta over cos theta, and then times 2 sin theta over 2 sin theta. You see that? So we get our lowest common denominator there, then sin theta times cos theta. Okay, almost there. Then what do you do? Let's simplify this fraction here. So it becomes cos squared theta minus sin squared theta plus 1 over 2 sin theta times cos theta plus 2 sin squared theta over 2 sin theta cos theta. Okay, so we have our LCD now. We can then add the numerators there. So it's going to be, we're going to add the numerators. So let's add cos squared theta minus sin squared theta plus 1 plus 2 sin squared theta. Okay, right, let's just do that. So it becomes cos squared theta minus sin squared theta plus 1 plus 2 sin squared theta, all this over 2 sine theta cos theta is equal to 1 over sine theta cos theta. Right, and then if we check, we have like terms here. What is negative sine squared theta plus 2 sine squared theta? That is sine squared theta. Okay, so if we come this side, so this becomes cos squared theta plus sine squared theta coming from these two. Sine squared theta is coming from these two. Okay, so it's going to be cos squared theta plus sine squared theta, then plus the 1. Okay, this one here. So plus 1, okay, over 2 sine theta cos theta is equal to 1 over sine theta cos theta. Right, and then remember we talked about this is an identity. Cos squared theta plus sine squared theta is 1. So it's going to be 1 plus 1 over 2 sine theta times cos theta is equal to 1 over sine theta cos theta. Right, and then this is 2 over 2 sine theta cos theta is equal to 1 over sine theta cos theta. Then 2 divided by 2 is 1. Okay, then we remain with 1 over sine theta cos theta is equal to 1 over sine theta cos theta. Right, and then which is left hand side is equal to right hand side. Right, this is our question 3A1. It was a long one. I don't know how many thetas I said here, but okay, that's what we're supposed to do. So you don't need to do all the 3 in the exam. Just choose one. You do one when you get a question like this. Okay, you just do one and then you'll be done. Okay, thank you very much. We're going to meet when we do question 3A2.